Hello students, welcome to IMS GATE Academy. In today's session, I am going to discuss 10 challenging questions of EDC. The students can also try these questions. If you are not getting answer, you try to check my video and stand now. Yes, I will start the questions one by one now. The first question. Any student can try this question at first? Any student can try this question without my help. The question here given is Fermi level of any doped silicon semiconductor is 0.3 electron volts. Above the Fermi level, above the Fermi level only. Above the Fermi level of undoped semiconductor. Assume T equal to 300 Kelvin, thermal voltage 26 millivolts, Ni equal to 1.5 into 10 power 10 per cm cube. Then doping concentration and type of the semiconductor is. Which type of semiconductor it is needed at first. Then after we can calculate, is it a, what we have to calculate here now? We need to calculate doping concentration required. Doping concentration means is it electrons concentration or holes concentration? We need to calculate only now. Once you know the type of the semiconductor, you can understand what concentration we need to calculate here now. But in the problem strictly given here now, semiconductor is 0.3 electron volts above the Fermi level of undoped semiconductor. Above is an undoped semiconductor means intrinsic semiconductor. The intrinsic semiconductor can have the Fermi level, intrinsic Fermi level only now. Just above that, above means what now? It is an n-type extrinsic semiconductor only now. Below intrinsic semiconductor, the Fermi level energy is given means it becomes a p-type extrinsic semiconductor. Now we can say the type of the semiconductor is n-type. Directly we can write. Type of semiconductor is n-type extrinsic semiconductor. N-type extrinsic semiconductor. One point is clear. So here I got the n-type, here also I got the n-type. But the concentration is because the A and B is not correct. That is clear because A and B with p-type only here given now. That is not correct here now. And we need to find the concentration. What concentration we need to calculate here now? The concentration of electrons here required because it's an n-type extrinsic semiconductor. We know one more point clearly. For n-type extrinsic semiconductor, N is approximately equal to Nd, donor concentration. N is approximately equal to Nd. So the formula for the N we know. Wherever N is there now, directly you can put donor concentration. That is the concentration of electrons. That value we can determine here now. I say the concentration of electrons, N equal to formula is there now. Ni into e power EF minus EFI by KT. This is the general formula. EFI by KT we are going to use generally. EF minus EFI divided by KT. This formula we are going to use generally. Where N is approximately equal to Nd, we know very well. N is approximately equal to Nd. So N equal to, I can write Nd. And Ni, intrinsic concentration, is given in the problem. What its value is given? 1.5 into 10 power 10. 1.5 into 10 power 10 we can write. E power, EF means EFN only now. Fermi level, Fermi level of the n-type extrinsic semiconductor. EFI means Fermi level of the what now? Intrinsic semiconductor now. But the EF minus EFI is given in the problem 0.3 electron volts above the Fermi level. This is 0.3 only now. So I can write EF minus EFI is nothing but 0.3 electron volts divided by KT. KT equal to VT only here now. KT, how we can find that it is not given in the problem. In the problem, it is not given, yes, it is given thermal voltage, but the KT equal to VT only now. That is nothing but 26 millivolts, given clearly, 26 into 10 power minus 3. Use calculator, you are going to get ND value. Use the calculator, you give its value. Its value is approximately equal to 1.54 into 10 power 15. 10 power 15 per cm cube is possible. Per cm cube is possible. This is the solution for this question. So which option is correct here now? Option C is correct here now. Option C is correct for this question. This is one of the problem. I will give one more question. You please try. The second problem here is this one. Anybody can do this question without my help? Any student can do this question without my help. But I will give some time, you start doing this question. I will read out the question here now. Mobility of any semiconductor due to various scattering parameters are given as 600 cm square per volt second and 650 cm square per volt second, 680 cm square per volt second here now. Respectively, the overall mobility of the semiconductor is dash, integer value required here now. How we can find the overall mobility? Overall mobility or total mobility, any name you can put now. The mobility in the semiconductor is possible by different factors only now. So because of those factors here, what happened now? Three different mobilities are here taken place now. The mobility of the first one is given, that is nothing but the mu1 is given in the problem. Mobility of mu1 is given in the problem, 600 cm square per volt second it is given here now. And a mu2 is given here, mobility due to different factor is given here now, 650 cm square. 650 cm square per volt second it is given here now. And one more mobility is given, that is nothing but 680 cm square per volt second. Mu3 also given, 680 cm square per volt second it is given. So these are the three mobilities are given. But is asking to find the overall mobility. That overall mobility is denoted by letter mu-t. Total mobility is how much? Is asking to find. Whatever the number of mobilities are given in the problem, you should use the formula 1 by mu-t equal to total mobility. If you want to find because of the factor of the other mobilities, you must use this formula. 1 by mu-t equal to 1 by mu1 plus 1 by mu2 plus 1 by mu3. If you are given the more than these three means you can add. Understand my point now. You can substitute these values and you can find mu-t value here now. I want to find mu-t. 1 by mu-t equal to 1 by mu1, 1 by 600 I can put here now. The 1 by mu2 is nothing but 1 by 650. 650 is given. The mu3 is given as a 1 by 680, 1 by 680 I can write here now. Now thereby required total mobility, mu-t is required. The total mobility mu-t is required. Its value is approximately equal to, 213, it becomes a 214 approximately. Mostly 213.87 something it comes now. But integer value is required. Integer means 214 what cm square per volt second. Cm square per volt second is possible. This is the solution of this question now. I hope you follow. Yes, I want to give one more question now. This subject is very useful for ECE people now, because the ECE students are having good weightage of these subjects. So you try to practice these questions, understand. And third question I will give in your hand. You please try this one. You can try this question. Yes, you start doing this question. You can start doing this question. But what is given in this particular problem? The electron mobility and hole mobility in silicon are 0.135 meter square per volt second and 0.048 meter square per volt second. Mobility of electron and mobility of holes given in the problem. At room temperature, these mobilities are at room temperature. If the carrier concentration is 1.5 into 10 power 16 per meter cube, if rho and what now, here the rho value and sigma value, if sigma and rho be the conductivity and resistivity of silicon at room temperature respectively, then choose the correct option. Here, two sigma values and two rho values are given now. Rho indicates conductivities and rho indicates the resistivity, sigma indicates conductivity. This is conductivity. Rho is nothing but the resistivity, we can say now. These are resistivity now. Two resistivity values, two conductivity values are given because whenever you are given two rhos and two sigmas means we can say it is a MSQ question only now. What way we can tackle? So we can tackle this question like this. In the problem it is given mobility of electrons given, mu n is given in the problem. Mu n equal to 0.135 meter square per volt second. And mobility of hole given here, mu p is given in the problem, that is 0.048 meter square per volt second I can put here now at room temperature. Carrier concentration is given, carrier concentration is nothing but Ni. Ni is given in the problem. Intrinsic concentration is given 1.5 into 10 power 16 per meter cube it is given. If sigma and rho be the conductivity and resistivity of the semiconductor, is asking sigma, conductivity is required and resistivity value is required. These two are required. What is the formula for this rho? Here the mobility of electron and hole given means it is a semiconducting material, you know very well. Anyhow, it is made up of silicon only given now. We know very well conductivity is sigma equal to Ni into Q into mu n plus mu p. By using this formula, you can determine conductivity. Ni is given in the problem 1.5 into 10 power 16. 1.5 into 10 power 16 it is given. That much value given here now. 1.5 into 10 power 16 is given in the problem. This is a Ni value. And what about the Q? Q is the charge. I can write 1.6 into 10 power minus 19. 1.608 into 10 power minus 9, approximately 1.6 into 10 power minus 19 I have taken now. Into mu n plus mu p. Mu n is given 0.135 plus 0.135 plus 0.048. 0.048. Yes, all the values here substituted here now. Now you can use calculator to get the sigma value. Conductivity you can get. The value of this conductivity is 0.4392 into 10 power minus 3 per ohm per meter is possible. 0.4392 into 10 power minus 3. So which option is correct? Option A is correct for what? Conductivity. For conductivity, option A is correct. And also in the problem is asking to find resistivity, rho value also required. The resistivity is nothing but reciprocal of conductivity, we know very well. So you can apply it directly, rho equal to 1 by sigma. 1 by sigma, conductivity is given in the problem. How much it is given? 0.4392 into 10 power minus 3. Use calculator, you will get rho value. Its value is 2276. 276.86 ohm meters possible here now. 2276.86 means option C is correct. So here A and C options are correct. I can say that now. For the given problem, options A and C are correct. It is a MSQ question. Yes, I will go to the next question now. The next question I will give now. You please try this question now. It's a very good question. I hope you can try this question without my help. You can try. What is given in this particular problem? An N plus P silicon diode at T equal to 300 Kelvin has the following parameters. Nd equal to 10 power 18 per cm cube, Na equal to 10 power 16 per cm cube, it is given. Dn is nothing but the diffusion coefficient, you know. Dn equal to 25 cm square per second, dp equal to 10 cm square per second. Tau n0 equal to tau of p0 equal to 1 microsecond. And A equal to 10 power minus 4 cm square, Ni equal to 1.5 into 10 power 10 per cm cube. The diode current for a forward bias voltage of 0.5 volts is dash into 10 power minus 7 amperes. Eta is given as a 1 only now. But in the problem is asking to find the diode current. Diode current is required in the given problem. The diode current, the approximate value of the diode current is calculated by ID equal to IS into e power V by, V means forward voltage, by eta into Vt. But eta is given directly in the problem 1. At the time I can put directly e power V by Vt only, you know. But in the problem what is unknown means the reverse saturation current Is is unknown. If you are getting Is value, it is very easy to determine diode current here now. I say in the problem it is given N plus P silicon is given. For N plus P concentration of electrons, N plus P is given, N plus P, you know. For N plus P, the reverse saturation current Is or I naught, you can denote any one of the letter. I suffix 0 or I suffix s, any one of the letter you can denote here now. Is is calculated by A into Q into Ni square into under root of dn by tau n0. By using this formula, it is determined reverse saturation current. If it is a N plus P means this is the formula you can apply. But if you got the P plus N, if it is given dP, but the same thing you can take dP by tau P0 you can use only now. But anyhow, how we can find this Is? In the problem it is given A value, Ni is given, Dn is given, tau n0 is given. By using these values you can determine reverse saturation current. Now I would like to find Is. So I can say Is equal to area is given in the problem 10 power minus 4. And the charge you know very well, 1.6 into 10 power minus 19. Ni, intrinsic concentration is given in the problem, intrinsic concentration 1.5 into 10 power 10. 1.5 into 10 power 10. But Ni square is required in the problem, whole square I can put now. Under root of Dn, diffusion coefficient of electrons 25 cm square per second, it is given, 25 is given in the problem. By tau n0 or tau p0 both are same, 1 microsecond only, 1 into 10 power minus 6. Now you calculate what is Is here now. Is value is nothing but, here I will put otherwise, Is value is approximately, it comes as 1.8 into approximately 1.8 into 10 power 1.8 into 10 power minus 15 amperes of current is possible. Reverse saturation current is always available very small, 10 power minus 5 means very less current only it is going to flow, reverse saturation current. By using this reverse saturation current you can determine diode current equation, diode current only now. But I am not going to use ID equal to what exact formula we know. Approximate formula we know very well. Diode current. That is nothing but IS into e power V by Vt. Because V by eta into Vt will know. But eta value given in the problem, one it says now. That is directly you can write V by Vt. The V is nothing but the forward voltage, forward bias voltage only. This is 0.5. IS you got as a 1.8 into 10 power minus 15 its value. And e power V equal to Vf forward voltage is given 0.5 voltage here now. Divide by thermal equivalent of the voltage is given or not given in the problem. Please check it now. In the problem it is not given Vt value. If it is not given, you can put it as a what now 26. 26 you can put now. 26 millivolts only. 26 millivolts only. If not given, you can put Vt equal to 26 millivolts only now. If you are using the calculator, you will get diode current. Diode current you are going to get approximately it comes as 4.36 into 10 power minus 7 amperes mostly possible. But here we can put 1.36 only now. Anyhow 10 power minus 7 is given in the problem. So on this is the answer for this question. I hope you followed. And I wish to give one more question, one more good problem I want to give in your hand. You please try to tackle this question now. Yes, this is one more good question. Can you tackle this question without my help? Is it possible to give answer for this question? You start doing this question and give answer. But I will wait for 2 minutes. Please try to give answer. Otherwise, I will also do here now. You can also try. If you are getting answer before my answer, you please message. An abrupt p-n junction under thermal equilibrium shows the electric field distribution with peak electric field at the junction minus 15 into 10 power 4 volts per meter is shown below. Then magnitude of the diffusion potential is dash volts. Is asking to find the magnitude of the diffusion potential only now. Magnitude of the diffusion potential, I would like to give the name of VBI, built-in potential only. Magnitude value, not required any negative sign, positive. Electric field intensity is given minus. Finally, built-in potential also will come with minus sign only now. But in the problem it is given directly, thereby required only magnitude of that built-in potential only now. So we can take positive value only now. So generally built-in potential is calculated by minus of integral E dot dl. This formula generally applied to find out the built-in potential only now. But otherwise one more way we can find in the problem it is given Wp is given, Wn, these two values are given. This electric field intensity is nothing but the E value only now. This is E value given here now. Minus 15 into 10 power 4 is given in the problem. But this built-in potential we can find in the electronic devices. In the p-n junction diode you might have studied. By using the profile of the electric field intensity versus distance, you can determine built-in potential also. The area of this electric field intensity profile you take it. That area whenever you calculated that can give the result of built-in potential only now. The area of this electric field profile will give the built-in potential only now. Understand now? You know very well now. But how we can find this VBI can be calculated by the area of this electric field intensity now. But how to find out this area? Half into area of the triangle, you know, half into height. Height is nothing but the electric field intensity. 15 into 10 power 4. Magnitude value is required. I don't want to take the minus sign here now. Why, sir? Reason is magnitude of built-in potential required. So I can put here now 15 into 10 power 4 volts per meter only. This is the height, half into height into the total distance. Wn minus half minus plus Wp. That is a total W. From here to here add up. That means WP plus WN can give the what not total width only now. The total width is nothing but 1 micrometer plus 3 micrometers, 4 micrometers possible. I can write 4 into 10 power minus 6, I can write here now. Then what is answer here now? This answer will be, the answer is 0.3 volts possible. VBI is nothing but 0.3 volts possible now. This is the solution for this question. I think you are getting clear concept of this question now. Now, I would like to give you one more good question in your hand. You please try to tackle this. You please try to tackle this question now. Anybody can do this question without my help? Any student can do this question without my help. What is given in this particular problem? An NPN BJT has applied collector emitter voltage VC equal to 1 voltage. Collector to emitter voltage is given in the problem, that is given as a VC equal to 1 voltage, for which collector current is 1 milliampere. IC is given 1 milliampere in the given problem. Given the early voltage is 100 volts. Early voltage also given in the problem, that is 100 volts. Collector current is dash in milliamperes for VC equal to 100 volts, accuracy up to 2 decimals. When the early voltage is given, how to find out collector current, that you have to know. Once you know that, you can do easily this question only now. I will give clarity now. But in the problem, what is given, you see, VC equal to 1 voltage, collector to emitter voltage is 1 voltage, collector current is 1 milliampere. That means IC1 is given when VCE1 equal to 1 voltage only now. But early voltage is given, lambda is given. This is to be taken as a lambda value, that is a constant value. Collector current I want in milliampere, VC equal to 100 volts. VCE2 equal to 100 voltage, what is IC2? They were required IC2. IC1 given, IC2 required. VCE1 given, VCE2 also given only now. They were required collector current now. How we can find? You please watch, I will do clearly. You know very well, collector current is determined if early voltage is given. If early voltage is not given, you know very well. That is to be taken as a, but that should not be considered in that problem only now. That is taken directly infinite value if not given, understand up. But I will take IC equal to, you know, IS into E power VBE base to emitter voltage of transistor divided by thermal equivalent of voltage into 1 minus 1 plus VCE by 1 plus VCE by VA. Early voltage VA, not lambda, sorry. This is early voltage, I can put as a what now? VA only. Early voltage is a VA. But 1 plus VCE by VA. This is the formula generally we are going to apply to find out the collector current now. Here I can say IC depends upon this factor I have taken here now, because VCE only changes in the problem. The change of VCE is changing the what now? Collector current now. So I wish to take here now IC is directly proportional to 1 plus VCE by VA I can put here now. Early voltage is constant here now. But my aim is to find IC2. I can write IC2 by IC1, I can write like this now. The proportionality constant will be cancelled. If you are dividing IC2 by IC1, whenever you have taken, it is cancelled, what now? Proportionality constant. Then I can get here now 1 plus VCE2 by VA divided by 1 plus VCE1 by VA I can get now. On simplification I can get VA plus VCE2 divided by VA plus VCE1 I can get now. But thereby required IC2 value, I want IC2 value. So VA plus VCE2 by VA plus VCE1 multiply by IC1. By using this formula, you can determine collector current. But you know every one of the value. Early voltage is given 100 volts here now. 100 plus VCE2 is given 100 volts here now. Divided by VA is nothing but the 100 here. VCE1 is given 1 voltage here now. Multiply by IC1 is given 1 milliampere. 1 into 10 power minus 3. Use calculator, you will get IC2. This value will be approximately equal to 1.98 milliamperes. This is approximately equal to 1.98 milliamperes possibles. This is the solution for this question. I hope you followed. That way we can tackle now. Next question. Next one more good question I will give. You please try this question. Yes, this is one more good question only. You please try this question. It's a very simple question. Anybody can do. I hope. Anybody can give answer for this question? Any student can give answer for this question. It's a good question. It's a very simple question. Logically we can complete. Not required any formula also here to do. What is given in this problem? A PNP BJT has a minority carrier profile as shown in the figure. This is the profile of the minority carriers in PNP transistor. The region of operation of BJT is asking to find the region of operation. Is it in saturation or cutoff or otherwise active, reverse active is asking to find. In an easy way I will explain, you can understand. But in this particular graph it is given the what now emitter junction is given, collector junction is given in the problem. Emitter junction and collector junction is given. The minority carriers profile is given. The minority carriers are increasing here now. At the emitter junction it is increased from this point to slowly exponentially it is increased and reaches to the maximum only now. But here it is rising. Rising means it is increasing only now. At the emitter junction, concentration is more. More concentration you got here now. The more concentration whenever you got at the emitter junction, you can say this is forward bias. Emitter junction is forward bias, you must say. When minority carriers at the emitter junction, if you have more, you need to say it is a forward bias only. You should watch at the collector junction how the minority carriers profile is given there now. But at the collector junction we are finding the very less concentration, very less, slowly it is decreased and reaches to this point, 0 level only we got. Close to close to this point only now. Very close to the junction, very less concentration I got. Here at the collector junction, I got a less concentration. If you got very less concentration, you can write directly it is a reverse bias only now. Collector junction is reverse biased, you need to put. You know very well, emitter junction is forward bias and collector junction is a reverse bias, means the region of operation of the BJT is forward active region only now. So I can write the region of operation. The region of operation of BJT is forward active region. Forward active region we can say. Such a way you can get answer very fast. It doesn't take more time only. Based upon the profile of the minority carriers at the collector and emitter, you will come to the conclusion to give the region of operation of the BJT. Next question. Yes. Can you try this question without my help? Can you try this? One more good question. I wish to give in your hand. Start doing this question without my help. Start doing this question. What is given in this particular problem? The CV curve of step graded PN junction is given in figure below. The built-in voltage of diode is dash volts. CV curve means capacitance of the capacitor in microfarads. This voltage is nothing but the voltage only. What voltage? Reverse voltage only. Negative values are given. Reverse voltage is given the problem. Reverse voltage is given. Reverse voltage given to the PN junction diode. But reverse voltage is given to the PN junction diode means you can say junction capacitance versus reverse voltage is given in the problem only. Nothing more than that. But thereby required built-in voltage of the diode. How to get the built-in voltage? Built-in voltage is generally calculated like this now. Solution I can write now. Junction capacitance Cj is directly proportional to, junction capacitance is directly proportional to 1 by VBI plus VR. Generally formula is a VBI minus of reverse voltage. Reverse voltage is a minus value. Suppose minus 6 is there, means minus of minus plus. While taking the VR value, you must take 6, 5 magnitude values only. Why means this is converted into a plus only. General formula VBI minus VR. VR is a minus plus directly. How taken there now? Understand my point now. And I would like to, what now? I would like to get here now. How I can get here now? When Cj equal to C equal to, otherwise C you can put now C1, C2, C1, otherwise I can put now C1 is directly proportional to 1 by VBI. VBI I would like to put here now. VBI, directly you can write now. Still easy way I will do now. You will understand clearly. The built-in potential I can get by using this formula only. VBI is the built-in potential here now. But here I wish to take junctions with C1 by C2 value I want to put here now. C1 by C2 means what I can do? C1 VB2. C1 means 1 by VBI. 1 by built-in potential is constant, VR1 here. C2 means proportional to constant, cancel. C2 means 1 by means it goes to numerator. VBI plus VR2 I can write now. By using the formula we can determine C1 by C2 value. Substitute the values getting from the CV curve. Just to take the values from the curve, this curve directly. What is given here now? The VR equal to here the 0 voltage only, this voltage. This voltage is to be taken 0 voltage. VR1 I can take it as a 0 voltage. VR1 0 voltage means from the CV curve the capacitance of the capacitor or junction capacitor is nothing but 1 microfarad. C1 equal to 1 microfarad I can put here now. The next one is nothing but when VR equal to minus 6, the corresponding value of C junction capacitance is 0.5 microfarads only now. I can say, but I will not put the minus 6 because that minus when substituted VBI plus VR magnitude value, VR equal to 6 voltage directly you put it now, magnitude now. I say VR2 equal to 6 volts. But don't put minus 6 because minus of this minus plus here I have taken here now. 6 voltage, the capacitance of the capacitor C2 value is nothing but 0.5 microfarads. 0.5 microfarads I can put now. Now these are the values I can substitute in the above equation. C1 I got as a 1 micro divided by C2 is nothing but the 0.5 micro. That equal to VB1, VBI we want to find with root only, sorry. This is 1 by VBI with root only possible. I made a mistake. Please cross check this formula. With root you are going to get. With root you are going to get only now. Must only now. The root is not taken, you will lose the marks only now. Understand now. Anyhow, this is required. So VBI plus VR under root of directly one single root I can use here now. VBI I can put as a what? We need to find VBI. Plus VR2 is nothing but the 6 divided by VBI. We need to calculate. VR1 is given as a 0 voltage only now. So by simplifying this equation, you can get VBI, built-in potential, you will get directly. Its value is around 2 volts it comes. VBI is 2 volts you will get. Built-in potential is 2 volts here possible. This is the solution for this question. Follow this? It's a very simple question now. By using the curve you must find. Very good question also. And I wish to give one more question here now. One more problem I want to give. From the MOSFET I want to give one more question in your hand. By using the MOSFET I wish to give one question in your hand. You start doing this question without my help. I will wait for few minutes. Please start doing this question. What way we can tackle this question? But what is given in this particular problem? For a MOS capacitor formed on p-type silicon substrate doped with Na equal to 5 into 10 power 16 per cm cube, the surface potential required to make the surface at strong inversion is dash volts. That is a given problem. Strong inversion, that point is very, very important. The surface potential is needed in the problem. What is given? Na is given. He is asking to find the surface potential. Surface potential is given a symbol of phi suffix s. That value equal to how much? But I wish to say at strong inversion, if it is given strong inversion, you must use. At strong inversion, the phi s equal to 2 times of phi f, 2 times of phi f, Fermi level potential. 2 times of phi f is the phi s only for strong inversion. If it is not given the strong inversion, it is a weak inversion is given, means you must take phi s equal to phi f only. Phi s and phi f are equal. One in the strong inversion you will put phi s equal to 2 phi f only. Sir, what about that phi f's are Fermi level potential? How I can get this value? The phi f is calculated by kT by Q into ln of natural log Na by Ni. Na by Ni. This is the formula generally used. Na by Ni. In the problem it is given Ni value 1.5 into 10 power 10 per cm cube. KT by Q is not given. KT by Q can be taken as a thermal equivalent of the voltage. Vt we know. Vt equal to 26 millivolts we know very well. So I wish to find at first what is phi f. The phi f KT by Q is to be taken as a 26 milli 10 power minus 3. Ln of Na is given in the problem 5 into 10 power 16. 5 into 10 power 16 is given in the problem. Divide by Ni. What is Ni? 1.5 into 10 power 10. 1.5 into 10 power 10, that is given. Finally, the phi f value is 0.391. 0.391 volts. These are all the potentials only now. At the time it is to be taken with units volts. After getting the phi f, you can find the surface potential. It is asking to find the surface potential only. Surface potential is required in the problem. That is phi suffix s. So phi s equal to, I can write 2 phi f given. 2 into phi f is to be taken as a 0.391. Finally, its value is 0.782. 0.782 volts possibles. That is the surface potential. So far I have done 9 problems. Last question, one theoretical question I would like to give in your hand. You please give answer very directly. Sometimes you are but you can expect theoretical questions also from the in the subject of electronic devices and circuits. In EDC, asking certain questions from theory part. This is the next question. Anybody can do this question without my help? I'm expecting answer from your side. Please write. What is this question? The amount of gate oxide capacitance is determined by option A, charges present on the gate, option B, polarity of the gate, option C, charges present on the substrate, option D, area of the gate. Which option is right? It's a very simple question only now. Directly you can write here now. The amount of the gate oxide capacitance is determined by the amount of gate oxide capacitance is determined by area of the gate only. Based upon the area of the gate, the amount of the gate oxide capacitance is determined only by area of the gate. Area of the gate only. Area of the gate means which option is right here now? The option D is correct in this particular problem. So all the 10 questions I did now. Just you can practice. This will help you to boost up your level only now. I hope you followed so far. Thank you.